Hi grade 10s and welcome to this video. In this video, we'll be working on KZN's Mathematics grade 10 test, and this is specifically a term 3 test for 2023. Okay, this is a short test. It is worth 50 marks and it has a total of 6 questions. Okay, so let's get into this video. Question 1 says, the following is an arithmetic sequence, and we have 6, 1, and -4. And the first question, 1.1, says, write down the next 2 terms. Okay, so it is an arithmetic sequence, so it is a linear number pattern. So that means we have a constant difference. So do you see that from 6 to 1, right? We must have said -5. 6 minus 5 is 1. And then from 1 to -4, you must have also said -5. Okay, 1 minus 5 is -4. And so to get the next term, you just say -4 minus 5, which gives us -9. And then the term after that would say that -9 and then -5, which gives us a -14. And these are our next 2 terms. Moving on to the next question. The next question, 1.2, says, determine the general term of the sequence. Okay, so we need to get the formula of the sequence. So remember, it is an arithmetic sequence or linear sequence, meaning its general term is in the form of Tn equals dn plus c. Now, the value of d here, that is simply just the difference. And you can see that each time to get to the next term, we just say -5, and that would be our difference. So this is Tn equals, and we have -5n plus c. And now the only thing missing is that c. To find c, we're just going to take one of the terms that we have here. You can take the simplest one. This term has a term value of 1, right? And you can see that it is the second term. So what we're saying is term 2 is equal to 1. And so I'm going to substitute that info in here. Term 2 is equal to 1. So I'm saying term 2, meaning in place of n, we have substituted 2. So we'll say term 2 is equal to, so wherever you see n, you substitute 2. And then plus c, and we already know the value of term 2. It is 1. So 1 equals, and when we multiply, we get -10 plus c. And then we have 1 and transpose the -10. So it becomes +10 equals c. And so finally, c is equal to 11. And now we know from this that Tn is simply equal to -5n plus 11. And that is our general term. Moving on to the next question. Question 1.3 says, determine which term of the sequence is -114. So which term of the sequence will this be? So think about it with what we have here. If I had to ask you, which term of the sequence is -4? So you can see this is -4, and the term it belongs to is term number 3. Okay, so they're asking which term of the sequence has a value of -114. We're trying to find the particular term that has this value. So in place of Tn, we're going to substitute -114. So since we have our general term formula, in place of Tn, we're going to substitute -114. So this is Tn equals, and we have this. Okay, I'm just going to already replace it. So we're saying -114 equals -5n and then plus 11. And all we are doing is solving for n. So I'm just going to make this positive by transposing. And it's now +5n is equal to, and we still have 11 on the right hand side. Then if the -114 comes over, it becomes +114, which is, so 5n equals, and we have 125. And then divide both hand sides of the equation by 5 to get n alone. And we can see that n is equal to 25. So this just means that term number 25 has a value of -114. And that is our answer. Okay, so that is it for this question. And that is the last question for question 1. Question 2 says the following pattern is given. And we have 7x squared and then 5x squared minus 2x. That's the second term. And then we have 3x squared minus 4x. Okay, so we can see the separate terms. That is term 1, this is term 2, and this is term number 3. And they want us to show whether the pattern is linear or not. So what makes a pattern linear? If a pattern is linear, it means that it has a constant difference, okay? So whatever you add to this term to get to that term is the exact same thing you would add to this term to get to that term. And how we find that constant difference is like this. You always take the next term minus the previous term. So let's find the constant difference in these three terms and just see if it really is exactly the same. So we'll first find the constant difference by saying term 3 minus term 2. And let's see what we get. So that is 3x squared minus 4x, and then minus, we are subtracting by something that has more than one term, so use brackets. And we have 5x squared minus 2x, and let's simplify. So 3x squared minus 4x, and then minus 5x squared, and that becomes a plus 2x. And so this is equal to, and so these two would subtract to become negative 2x squared, and these two would become negative 2x. Okay, so that is what the difference is when we say term 3 minus term 2. Let's find the difference if we now say term 2 minus term 1. If it's exactly the same, then we know that this is indeed a linear pattern. So term 2 is 5x squared minus 2x, and then if you say minus, it's just minus 7x, okay? Term 2 minus term 1, so 7x squared. And so this gives us, we're going to subtract then get a negative 2x squared as well, and a minus 2x. Do you see how the difference is consistent? Okay, so because we can see that the difference when we say in term 3 minus term 2 is exactly equal to the difference, okay, when we say term 2 minus term 1, then this is a linear pattern because we are actually adding the same difference to get to the next term each time. So we can finally just conclude that, therefore, the pattern is linear. Okay, so there we go. Moving on to the next question. Question 2.2 says, if x is equal to 4, determine the constant difference. Okay, so they're already telling us the value of x. How did we find the constant difference initially? We went ahead and found it in two ways, and we can see that that constant difference is this. So we know our constant difference is negative 2x squared minus 2x. But now x is equal to 4. So just substitute. So negative 2, and then in place of x, we say 4 all squared minus 2 and 4. So this is equal to 4 squared is 16, and then times 2 is 32. So negative 32, and then that is just minus 8 when they multiply. So finally, our constant difference is negative 40, and that is our answer. Okay, moving on to the next question. Question B says we need to determine the value of the 10th term. Okay, so they're asking for term number 10. So for us to do this, to find the 10th term, because we know we can't just start counting term 3 and then term 4 and then we keep going, we clearly need to find the nth term first, okay? The formula of this pattern. So if we find that, we can easily find term number 10. Okay, so we know that it is a linear pattern, so it's going to be dn plus c, and our difference is negative 40. So we have negative 40n plus c. So now just find c using one of the info that you know. Take the easiest one. We have t1 equals 7x squared, okay? Since we know what x is, we can just find the value of term 1. Okay, remember that x is equal to 4. They already told us that. So this means that term 1 is simply 7 times 4 all squared. And that is going to be 16 times 7. 16 times 7 is 112. So term 1 is equal to 112. And we can use this info here. So we are saying term 1 equals, and this is just to find c. Okay, term 1 is equal to negative 40. And then in place of n, we substitute 1 and then plus c. And now term 1, we know that this is 112 is equal to, and that becomes minus 40 and then plus c. Then we can transpose. So this is 112 plus 40 equals c. Therefore, c is simply equal to 152. Okay, so our formula is Tn equals negative 40n plus 152. And then we can now use this to find the 10th term, which is what we're looking for. Okay, so term number 10 equals, and in place of n, substitute 10 in this. So we'll say negative 40 and then times 10 plus 152. And let's get our answer. And you can see that gives us negative 248. So negative 248 is our answer. And that is it for that question, and that is it for question 2. Question 3 says, Mr. Temba has 3 children. Okay, 3 children. It was found that the ages of these children form a linear sequence. Okay, so we have a linear sequence with the ages of these 3 children. So 1, 2, and 3. With age difference of 3 years between 2 successive children, starting from the youngest to the eldest. Okay, so it seems like these are the 3 children that he has, right? And they are 3 years apart, starting from the youngest all the way to the eldest. Okay, so from the youngest to the next child, there's an age difference of 3 years. From that one to the eldest is an age difference of 3 years. Okay, so the eldest is older than this one by 3 years, and then this one is older than the youngest one by 3 years. Okay, from what we have here. And then they say 3.1, the age of the eldest child is 26. And now we know what that third term is. The third term is 26. Okay, so we have a linear pattern here. We have the third term, the third child being 26 years old. And the question says, if Mr. Temba continued to have more children, okay, so apart from these 3 children, have more children, what would be the age of the 7th child? Okay, so clearly the 7th child is going to be much older than 26. So we can see that what we have here is a linear pattern, and we have a linear pattern with a constant difference of 3, right? So third child is 26. And the only info that we know the third term is 26, but we also just know that the constant difference is 3. Okay, so from this info, you see that we can find the ages of the 2 other kids, but they didn't really ask for that. So we could find this one's age and that one's age, but they only specifically asked for the 7th child's age. So if he decides to keep having kids. Okay, so I'm now thinking about this, and the pattern specifically says it's from the youngest to the eldest. And I feel like this is where the problem comes in. If this pattern is going from the youngest to the eldest, then that means this is his youngest child already. If he has any more children, they will be younger than this one. And so if they're younger than this one, it would make this child not the third child anymore. Now, that would mean we would have to look at this pattern in reverse. And it shouldn't go from youngest to eldest. It should go from eldest to youngest. So we could look at the eldest child as term 1, since he's deciding to have more kids now. The new kids that come, they will be younger than these ones. So if we're actually looking at it from eldest to youngest, then we know that the eldest child that he has is 26. And then, so that would be our term 1. And then the next child would be 3 years younger, 23. And then 20. And then 17, and then we will be able to find the 7th child. So logically speaking, I will go with this approach. And I think this youngest to eldest thing, that is where it just gets a little confusing, because it wouldn't make sense to go this way now from the youngest to eldest, since if he has more children, okay, they would fall here. They would be younger than his current youngest child, okay? Okay, so in a nutshell, the 7th child would not be older than this one. The 7th child would be much younger, okay, because he's having more kids. And so, if you have new kids, they're going to be younger than the ones that you already had. Okay, so I'm going to go with this approach and not rewrite this pattern from youngest to eldest, because then it wouldn't make any sense. So this is the pattern that we have. We know that we keep saying -3 each time to get to the next term, okay, to get to the next child, since they're 3 years apart. Okay, so that's -3 to get to the next one. And so how would we get to term number 7? So you could actually count and then just get to term number 7, child number 7, and then you would find this. Or you could also just find the pattern. It is for 3 marks, so you can either find the pattern or actually just find this child. I think it's fine like that. So term 2, term 3, term 4, 5, 6, and 7. So we can actually see how old this child would be. So -3, that would be 14. Then -3, that is 11. -3, that would be 8. The 7th child would be 8 years old. So we could do it like that and say the 7th child is going to be 8 years old, or we could have found the formula for this pattern. But the formula for this pattern, you see that you would have to reconstruct it. You can't actually write it from the youngest to the eldest because then it's not going to make sense. Then his child, who is 26 years old, is not the third child anymore. Okay, so yeah, we can actually just find it like this. So the seventh child would be 8 years old. Okay, and that is our answer. You can just show the pattern or actually just find the TN formula like the way we did in questions 1 and 2. Okay, it's a linear pattern, but just remember that your constant difference would be 3, and that first term is actually 26 because the eldest child is 26. Okay, so that is it for that question. Moving on to the next question. Then next question 3.1.2 says, what will be the age of the last born? Okay, so if this pattern continues, what would be the age of the last born? You see, this kind of pattern question is something where we have to think more about logic rather than just counting. Okay, if you just took everything literally, then, things could actually go wrong here. So currently, the youngest child we have right now is 8 years old. But if he continues having kids, okay, like they said if you were to continue having more children, so we have to find the seventh child. Now, what would be the age of the youngest child? So if we are going from 8 and you know that they are all 3 years apart, so we say mine is 3, and then that next child is going to be 5 years old, and then mine is 3, and that next child is going to be 2 years old. And so you see that if you say mine is 3, you're going to get a -1. We know that can't happen. That child is clearly not born then. Okay, so this would be the last child. And so the last born is 2 years old, and that is our answer. Okay, so there we go. The last born is 2 years old. Moving on to the next question. Question 3.1.3 says, determine the average age of the first 5 children. Okay, so the average age. So from the way our pattern is, we're going to pick the first 5 children, and then their average, we'll get the average. So that is the 26-year-old, the 23, the 20, the 17, and the 14-year-old. And we're going to add their ages. And to find an average, you take those ages, you add them together, and then you divide by the number of children that we have. Okay, so divided by 5. And so we will get our average like this. And the average age is 20 years. Okay, so the average age is 20 years, and that is our answer. Moving on to the next question. And then the last question, 3.2, says, would Mr. Temba be able to have children indefinitely? Obviously, no. Give a reason for your answer. So, no, because he's not immortal. Okay, can't have children forever. He's going to die eventually. Okay, so that is that. That last question was not really a maths question. It's more like a logic question. Okay, so just being realistic about it. So that is it for the last question, question 3.2, and that is it for question 3. Question 4, and just take note that you may make use of the following formulae in questions 4, 5, and 6. So it's all based on measurement. Before going into question 4, let's just go ahead and look at the formulas that we have here. So you'll notice that some of the formulas are for the volume of a shape. Okay, that's a volume. And some of them are for the area, the total surface area of a shape. So we first have volume equals 1/3 area of the base times the height. Now, part of this formula, okay, is really just the general formula of a 3D shape. When you have a 3D shape, let's take something simple, a rectangular prism. If you wanted to find the volume of this shape, you can just find the area of the base and then multiply by the height. Because if you do that, you get the area of the base and then times the height, you get the full capacity that this 3D shape can hold. But you would notice that this says area of the base times the height, but then it also says times 1/3. This is the volume, well, it's a volume that can be used for a pyramid. So the minute you see 1/3, okay? So it can be used for a pyramid with any type of base, really, regardless of whether it is a square base, a rectangular base, even a triangular base. You're still finding the area of the base, and then you're saying times the height and then times 1/3. Okay, so it can be used for a pyramid. It can also be used for a cone. Okay, so if you find the area of the base, in this case, which is a circle, and then multiply by the height times 1 over 3, you'd get the volume of this cone. Okay, so it can be used for a pyramid and a cone. And then let's go ahead and look at the next one. This just says length times breadth. We know that that is the area of a rectangle. Okay, so if you have a rectangle, just find the length, multiply by the breadth, you get the area of it. Okay, so that's of a 2D shape. And then we have the total surface area, 4 pi r squared. This is the total surface area of a sphere. Okay, so the 3D shape of sphere. That is the total surface area. And then the next one, we have 4 over 3 pi r cubed. Okay, so this is the volume of a sphere. Then the next one, this is the volume of, just see what we have. We have pi r squared times the height. That's the area of a base, a 2D base, and then times the height. But you can see it's pi r squared, and we know that pi r squared is the area of a circle. So this is clearly the area of a cylinder. Okay, so we have that. Okay, as you can see, that would be the area of the base, pi r squared, which is a circle, and then times the height. And so you get the full capacity. And then we also have the total surface area of this. The minute you start seeing, okay, times the slant height, this is for a cone. Okay, so the thing about a cone is we have two parts in a cone, as we can see with this shape over here. We have the circle, which is the base, and then we also have this part around it. So that's the pi r squared for the circle, and then this is for the body of the cone. Okay, so that is the total surface area of a cone. Okay, so we have everything, and now let's look at question 4. So question 4 says, a right pyramid has a square base of side 8 centimeters, as we can see. Okay, this is a square, and a height of 90 centimeters. So this is the height from the ground, okay, of that square, in the middle of the square really, and then to the highest point. And then they say determine the length of the slant height. Okay, so the slant height is this height. It's really just the height of a single triangle. So that height. So from the highest point of this triangle that we can see here to the base of the triangle, that line is going to be perpendicular to the base. So to find this slant height, look at what we can construct. So this height is going to go from the highest point of the triangle, and then it goes to the midpoint of this line. And then we can construct the line from the middle of the square and then all the way to that line that we have constructed. And just note that this line that we have drawn, right, this line is parallel to this line. And because this is the middle of the square, then if this length is 80 centimeters, and we can see that this point is right at the center of the square, that means from the center to the edge, we have 40 centimeters, okay? So this is a 40 centimeter line, and then we have a height of 90 centimeters. So you see that we have created a right angle triangle here. And so to find that slant height, we're just trying to find the hypotenuse of this right angle triangle. Okay, so using this triangle that we have here, to find that slant height, okay, we'll say s squared, we're using Pythagoras, is equal to the shorter side squared, okay, so 90 squared plus the other shorter side squared, and that is 40 squared. And let's go. So s squared is finally equal to, and that gives us 9,700. And then we can square root both hand sides. Remember that we don't have to consider negatives since we are just working with lengths here. So finally, s is equal to 10 square root 97. And of course, you can also round off, but it's fine like this. These are in centimeters, so it's just centimeters. And that is our answer. Moving on to the next question. The next question, 4.2, says, calculate the volume of the pyramid. You see that from the shapes that we looked at, the volume of the pyramid is this. So let's go ahead and take that. We'll just go ahead and tell them this is the volume. The general volume is 1 over 3, and then multiply by the area of the base of that pyramid, and then multiply by its height. So this is equal to, you see that our pyramid has a square base. So to get the area of the base, you would just say this 80 times 80, and that would be the area of that square. So we'll say 1 over 3, then multiply by 80 times 80, or 80 squared, and then multiply by the height of the pyramid, not the slant height. the slant height is the height of an individual triangle, but the height of the pyramid itself is 90 centimeters. So just say multiply by 90 and let's get our volume. And that is 192,000 and it's centimeters cubed. Because we are working with volume, you multiplied 3 centimeters together. So there we go. And that is our answer. Moving on to the next question. And then the last question for question 4 says, calculate the total surface area of the pyramid. Okay, so how do we find the total surface area? Total surface area of a pyramid. It's not something they put down here, but the thing is, we don't really need the formula itself. You see, they only gave you formulas of things that, you would really need help with. But with this, we don't need the formula of that. Total surface area just means find the area of all the sides in this particular shape. So in this case, I'm just going to take the actual areas of every single thing that I can see in this shape. So that is the area of the square. Okay, we'll take that. And then do you see that this pyramid has 4 other faces? It has a triangle here, one on this side, one here, and one here. So it has 4 triangles. And in each of these triangles, do you see how we have the height of the triangle? That was that slant height. We have that already. And we also have the base. To find the area of a triangle, you simply just say a half, multiply by its base, and then multiply by its perpendicular height. We have that height. That is the slant height. Okay, so the total surface area, we'll just say the area of a square, okay, or we could even just put it down. It's the area of a square and then plus the area of the triangles. But we have more than one, of course. And so the area of a square is just side times side, which is side squared. And then we'll add this to the area of our 4 triangles. So we have 4 multiplied by, and the area of a single triangle is a half, multiplied by its base and then multiplied by whatever its perpendicular height is, which was our slant height in this case. So side squared, remember that the sides of this pyramid is 80 by 80. Okay, that slant height, we already have that to be 10 squared root 97, or just keep that in mind. So this is 80 squared plus, and then we have 4, and it's a half, multiplied by the base, which was 80, and then multiplied by 10 square root 97, and this would give us our answer. Okay, so as a decimal, this is 22,158.17 centimeters, and remember it is area, total surface area, so it's centimeters squared, and that is our answer. And that is it for question 4. Question 5 says, a composite structure for storing grains consists of a cylindrical base. Okay, so this is the cylinder we have. And they say it is closed at the bottom. And a conical top. So this is the cone that we have, as shown below. The height of the structure is 170 centimeters in total. Okay, and the height and diameter of the cylindrical base is 90 centimeters and 80 centimeters respectively. Okay, the slant height of the conical top is S. Okay, so do you see from this, and let's actually just construct that already. If they told us that the entire shape is 170 centimeters high, and we can see that the cylinder itself is 90 centimeters high, then that tells us the height of the cone. Okay, so the height of this cone is 80 centimeters. So just keep that in mind. Okay, because you can just say 80, then plus the 90 gives you the full 170 centimeters. Okay, so the first question, 5.1 says, write down the radius of the conical top. So what is the radius? Well, the radius of the cone would be the radius of the cylinder. If we can see that the diameter of that base, the circle, is 80 centimeters, that's also the diameter here. And we know that the radius is half the diameter. It's from the center to the circumference. So that would be half of 80, which is 40 centimeters. And that is our answer. Moving on to the next question. Then question B says height of the conical top. So we just spoke about that. You see how that is 80 centimeters because 80 plus 90 would give you the full 170. So we know that that is 80 centimeters. And that is our answer. Moving on to the next question. Question 5.2 says, determine the lateral surface area of the conical top. So when they ask for the lateral surface area, you see this is referring to the cone. You see that the cone has two parts, right? We discussed this in question 4, and we're going to have to keep looking back at these formulae just to understand that. A cone has two parts, okay? It has this body, and then it also has the base. When they ask for the lateral surface area, they mean exclude that circle, that circular base, okay? So just the sides of it. Now we see from the total surface area of a cone, it has two parts, okay? The pi r squared, which is the circle, and we discussed that, and then the pi r times the slant height. That's what we need to focus on. Pi r times the slant height. So you see that the only challenge here is we just have to find that slant height, which is S. Okay, so let's focus on that. We're just finding the total surface area, we'll say total surface area, and we are going to specifically just use pi r times the slant height, so we can just get that area around, okay, the cone. Okay, so let's go ahead and look for that slant height. So in the previous question, you saw how we did that with a pyramid, right? With a cone, it's a similar situation as well. So the radius of this cone is 40 centimeters, okay, from the center to the circumference of the circle part. And we know that the height of the cone is 80 centimeters. Do you see how we can use this to find the slant height? So we'll look at this 2D shape, this triangle, and using Pythagoras, since we have one side and this side, we can find that slant height, which is also the hypotenuse of this triangle, this right angle triangle we have. Okay, so this is what we have, and let's go ahead and find that slant height. So I'll say S squared is equal to, and I'll take this side squared, which is 80 squared, plus this side squared, 40 squared. And let's get that S squared first. Okay, so this gives us 8,000. So it is 8,000, and then you just find the square root of 8,000, and that will be your answer. Okay, so I'll leave it as a surd. So square root both hand sides, only consider the positive because we're working with lengths. So 40 square root 5 is the slant height, and that's what we have. And these are in centimeters, so I'll leave it as centimeters. Okay, so now that we have the slant height, we can finally find the total surface area or the lateral surface area. So that's going to be, so let me not call it total surface area. We're not finding everything. So area equals, we'll say pi multiplied by, oh, I'll just pull this here. I suppose they're probably going to give you a mark for your actual formula, because in this case you have to think about that. So is equal to pi, and then we have our radius, which is 40 centimeters, as we see. Okay, so that is 40, and then multiply by 40 square root 5. And let's get our answer. Okay, so first, in terms of pi, all we have is, I'm just going to put that there, as 1,600 square root 5 pi. And then finally, I'll just round off. So A is finally equal to, we have 11,239.70 centimeters squared. And that is our answer. Okay, so that is it for that question. Moving on to the next question. Okay, question 5.3 says, calculate the total surface area of the entire structure. Okay, so we have parts of the structure now. We have the surface area of this part, but now the entire structure. So since this has been fixed onto this, we are not going to find the area of the circle part here. Okay, leave that out. We're finding the total surface area of the entire structure. Also note that they said it was closed at the bottom. So we also have to include this because it's not an open part, it's closed, meaning there's an actual shape there. Okay, so looking at all the things we need to find the total surface area of, we need to find the total surface area of this, and then the body of the cylinder, okay? And then we already found the total surface area of this top part, which we already have. So let's go ahead and construct. So the total surface area is equal to, we'll take the total surface area of that body, which was pi r times the slant height, then plus the surface area of the circle. But of course, let's just look at the body first of the cylinder. You see, when you take a cylinder and you decide to cut it and then lay it down flat, what you will get is a rectangle. But how we find the dimensions of this rectangle would look like this. You see, this part of the rectangle, that is the lining of the circle. That's the circumference. To find the circumference of a circle, we say pi times diameter. Okay? Or you can call the diameter 2 radius because it's double the radius. But pi times diameter is also fine. And then you would multiply it by the height because this is just a rectangle. So you're saying length times breadth. And then you'd find the area of that. So we'll say plus pi times diameter. Okay, I'll just leave it as diameter because they gave us 80 centimeters. I might as well just use it like that. Okay, or you can just say pi d. And then multiply by the height, which we will multiply that height. And then the last shape we need to consider is this part, the circle. Okay, the circle on the bottom, since this is a closed shape, the circle is actually there. And the area of a circle is pi r squared. Okay, so you see how we are finding the area of each part. That's that top part, the body of the cylinder, and then the bottom of that cylinder, which is a circle. And that will be the full total surface area. Okay, so let's find this. It's pi. Okay, we already found this one. Might as well just put it in. I'll leave the rounded off answer. Okay, regardless of whether you leave the rounded off answer or not, it really won't matter because you're still adding it to these ones. So let's just leave it not rounded off. That's fine. I'll leave it like that and then say plus, and we have pi, and we are going to multiply by the diameter, which is 80 centimeters, and then by the height specifically of this cylinder, which is 90 centimeters. So 90, let's just use brackets. So these ones are together, and then these ones are together, and then plus pi r squared, which is pi, and then the radius is actually 40, and then squared. And then when everything is added, we finally get 38,885 point, and that 8 is going to round the 1 up to a 2, so that's going to be 72. And remember, we are working with area, total surface area, so this is centimeters squared, and that is our answer. Moving on to the next question. The last question for question 5 says we need to calculate the volume of the entire structure. Okay, so the volume of the entire structure, yes, our structure is made up of 2 shapes, the cone and the cylinder. So first, let's start with finding the volume of this cylinder. We already know from this, okay, you can look back at the formulae that we have, but we don't really have to look at it. The volume of a cylinder is very simple. Because of the way the cylinder is shaped, we'll just find the area of the base and then multiply by the height. And that will give you the full capacity that this shape can hold. So that is going to be the volume of the entire shape. We'll just take the volume of the cylinder and then add it to the volume of the cone, and that would be our shape. So the volume of the cylinder, area of the base times the height. The base is a circle, so that is pi r squared multiplied by its height, and then plus the volume of the cone. So remember, this is a cone. You're still going to take the area of the base times the height, but then times 1 over 3, okay, because it's a cone. So that's the area of the base, pi r squared, then multiply by height, and then all of this is times 1 over 3, and that is our formula. Okay, so this is equal to, we'll just say pi, and then r is 40, so 40 squared, multiplied by the height of this cylinder, because that's for the cylinder, that is 90, and then plus 1 over 3, and then pi multiplied by r, which is 40. I don't know why I used brackets. I don't really need brackets. Okay, so 40 squared, and then times 40 squared, and then multiply by the height. And the height of that cone is 80 centimeters. So multiply by 80, and we'll get our answer. And our final answer is 586,430.6, and that 8 is going to round the 2 up to a 3. So 63 centimeters cubed, because we're working with volume, and that is our answer. And that is it for question 5. Question 6, the last question for this paper, says the surface area of the hemisphere below is 233 centimeters squared. Calculate the radius of the hemisphere to the nearest integer. So they've given us the surface area of this hemisphere. Not a full sphere, but a hemisphere. So let's go ahead and look at, remember, we already have the formulae for the surface area and volume of these shapes. So here is a sphere. The surface area of a sphere is 4 pi r squared. So you know that the surface area of a hemisphere, half a sphere, would be half of this. So you just take this and you divide it by 2. So that's going to give you 2 pi r squared. Okay, so that is all we are working with here. We know that our surface area, okay, of this sphere is 2 pi r squared. But then now I'm not really sure if they included this part, because if we're looking at the total surface area, well, they made it black. So they probably mean that, we're not considering that part. We're probably considering only this part. And so it would make sense. This part would be 2 pi r squared. If we were considering this part as well, we would have to consider that this is a circle. And so the area of a circle would be pi r squared. So you would have to say 2 pi r squared plus pi r squared, okay, to get that. So for this one, just in case, I'll do 2 calculations, okay, because I'm not really sure. They left it black, so I don't know if they mean it's included, it's not included. So let's just put that down. Okay, so find this separately. We'll look at a closed hemisphere and an open hemisphere. So with the closed hemisphere, I'm saying this shape is also included. So it's the body and that circle. So in that case, the total surface area here would be the 2 pi r squared, and then plus the area of the circle as well, which is pi r squared. And in the case that it's actually open and we're not including the circle, then it's going to be 2 pi r squared. So in both cases, this is what we have. We have the total surface area. The surface area is 233 centimeters squared. So we'll just say 233 equals, and in this case, you see that these are like terms. So they'll add together to become 3 pi r squared. And then we would just divide both hand sides by the number so that we can get to r. We're trying to find the radius. So pi is also a number. So divide both hand sides by 3 pi. So 3 pi here and 3 pi here so that it can leave. So once it's gone, you just have r squared left. So r squared equals whatever this gives us. So 233 over 3 pi. And then we find the square root of this. So you don't have to consider the negative here because a radius is a length. So r equals, and we'll find this. Okay, so in this case, it would be 4.97, and it is in centimeters, right? Okay, so centimeters, and that will be our answer. Now, in the case that it was actually an open hemisphere where this is not included, it would simply just be 2 pi r squared. And so for this, we would say 233 equals, you see, the thing is, had they left it in the same color, then I would already say, okay, then they clearly mean that this part is included. But they didn't. So I'm not sure. That's why I'm just going to put down 2 explanations for that. So that is 2 pi r squared. And then in this case, you see, you're just trying to solve for r squared again. But this time we have 2 pi here. So divide by 2 pi, divide by 2 pi. And finally, r squared equals 233 over 2 pi. And then square root both hand sides to get your final answer. So r equals here. In this case, it would be 6 point, and that 9 will round that 8 up to a 9. So 6.09 centimeters. And that would be our answer. Okay, so depending on which scenario they actually were referring to. And that is it for question 6. Okay, so that is the last question. Okay, you have these 2 options. And that is it for this paper. I hope you guys enjoyed it. If you have any questions, feel free to leave it in the comment section below. And I will see you in the future videos.